Imagine trying to find a specific tool in a massive 1,000-strong library of content. You know what you want to build, but you do not know the exact architectural terminology the authors use to categorize the pieces. When a user asks a traditional database to build Reddit, the SQL query executes, but returns 0 results. The search fails because it relies on exact string matching. The user wants community features, but the system is blinded by the literal text Reddit. This structural failure is known as the vocabulary mismatch problem. A common industry reflex is to patch this experience by placing an AI chatbot onto the website's front end, but a new chat interface fails to address the underlying inability of the database to retrieve the right information. To make a content management system actually understand what a user wants, the upgrade has to happen at the database layer. The system must be rebuilt to search by mathematical meaning. The first step in that database upgrade is the ingestion phase. Before an AI system can process large CMS records, the data must be prepared. This diagram shows a large block of text, like a Drupal module record, undergoing a mandatory process called chunking, where long text documents are sliced into smaller semantic pieces. There is a strict architectural trade-off here. Large chunks cause the system to lose precision. Conversely, chunks that are too small isolate the text, stripping away the critical context needed to understand what the sentence actually refers to. For structured CMS records like module directories or product catalogs, larger chunks are optimal. Each record is already a compact, self-contained unit of information. However, there is a lingering risk. Even with perfectly sized chunks, a fragment of text can easily become disconnected from its primary subject during processing. The technical solution is contextual content injection. By deliberately appending the record's primary title to the body text of every single chunk, developers ensure the AI always retains the overarching context. An AI model's output quality is dictated entirely by how rigorously the data is sliced and structured before the model ever sees it. Once the chunks are structured, they enter the vectorization phase. Here, the text is passed through an API and converted into numerical arrays. This 3D coordinate grid visualizes the vector database, specifically PostgreSQL operating with the pgvector extension. It plots these arrays of numbers as individual data points in space. Notice semantic clustering at work. Words and concepts with similar underlying meanings mathematically group closer together in this 3D space. When a user asks a question, that query becomes its own vector and lands directly next to the stored data points that share its context. The retrieval mechanism is literal geometry. The database measures the physical distance between the user's query and the stored content to determine relevance, but there is an absolute production constraint at this stage. Embedding models, the algorithms that translate the text into numbers, are proprietary and mathematically unique. Developers cannot mix and match providers. The exact same model used to ingest the database content must be used to process the user's query, or the spatial math fails completely. By translating human language into spatial mathematics, the system bypasses the vocabulary mismatch. It retrieves answers based purely on contextual proximity. Looking at the search radius, we can see that vector queries do not return a simple binary yes or no. They return a continuous spectrum of proximity scores, capturing some matches while explicitly excluding others. This creates the tuning paradox. A relevance threshold set too low floods the system with weak matches. If it is set too high, it misses vital, nuanced context. Sending high-volume token payloads of irrelevant results to a large language model drives up compute costs and creates a high risk of model confusion, ultimately degrading the final answer. Superior AI integration is achieved by ruthlessly optimizing for the exact right amount of context, rather than feeding the model maximum data. This baseline process of finding the closest vector match to a raw user query and passing it directly to a generator is known as naive RAG. Naive RAG operates well for simple searches, but it fails to address complex multi-component architectural questions. To handle multifaceted goals, the pipeline requires an upgrade to agentic RAG, a system designed to intercept and interpret user intent before searching. This flowchart breaks down the difference. When faced with a vague prompt like build Reddit, the agentic system's intent parser intercepts the query. It deconstructs the broad goal into actionable subconcepts like forums, comments, and moderation. The system then executes parallel independent vector searches for each of those deduced subconcepts, retrieving precise data for each component before synthesizing an answer. This multi-step reasoning carries a harsh production trade-off. It multiplies both the compute costs and the time required for token generation. Agentic RAG operates as a reasoning engine, capable of interpreting the unstated requirements behind a user's goal. We have just outlined an immense pipeline of external APIs, complex chunking logic, relational vector databases, and precise ingestion rules. Manually orchestrating this infrastructure requires hours of developer time before a client can ever see a working demonstration of semantic search. Environments like DrupalForge solve this bottleneck by dumping and importing a pre-indexed pgvector database. The moment the environment boots, the platform bypasses the initial processing costs and time delays. Applying AI at this infrastructure layer provides a more stable deployment than public-facing UI chatbots. Semantic search upgrades provide deep conceptual matching without the active risks of prompt injection or generative hallucinations. A vector-integrated CMS prioritizes the user's intent, moving away from simple keyword repositories to serve as an